Hello, everyone. My name is Natasha Maheshe. I work at AWS for AWS Analytics Product Marketing Team. And today I'll spend some time with you to talk about how you put your data to work with the best of both data lakes and purpose-built data stores. So let's get started. As you know, building a business that is sustainable for a long period of time is not easy. It really requires reinvention, likely multiple times over. Over 50% of businesses who were in the Fortune 500 list in the early 2000s are still there today. To be a leader that's going to reinvent, you really have to be maniacal, relentless, and tenacious about getting to the truth. Effective leaders rely on data to make informed decisions, look around corners, and take meaningful actions. The introduction of the cloud lowered the cost of storage and compute at scale, and as a result, it sets off a generation of reinvention. Now, as new ways to process and analyze large volumes of data become simpler and more cost-effective, we see that the next wave of reinvention is going to be driven by data. So building a data-driven organization and a data strategy is really imperative to stay relevant now and in the future. So what does a modern data organization look like? A modern data organization seeks the truth by treating data like an organizational asset, no longer the property of individual departments. They set up systems to collect, store, and organize and process valuable data, make it available in a secure way to the people and the applications that need it the most. They also use technologies such as machine learning to unlock new values from their data, such as improving operational efficiency, optimizing processes, developing new products and revenue streams, and building better customer experiences. However, to get there, customers need to overcome a few challenges. The first challenge that we have is the sheer amount of data. There's so much data that has been created. And the research shows us that in the next 3 years, there'll be more data created than in the prior 30 years combined. The old on-premise tools and data stores are not going to be able to handle this kind of scale. Second, organizations need to access and analyze all type of data, such as log files, clickstream data, voice, video, etc. This comes from a variety of sources and are stored in different silos. So to gain insights, organizations need to break down these data silos. The third challenge is machine learning. While machine learning can be a disruptive technology that fuels innovation, so many organizations today are still struggling to make meaningful progress because they lack the right machine learning skills. There's organizational inertia that's happening, and having the right quantity and quality of data to train on. Organizations that already have AI experience moved only 53% of their AI proof of concept into production over the past 2 years. That shows that many companies are still struggling today with the lack of machine learning skills. And it's quite difficult to actually get something from POC to something that your end customers can end up using. The fourth is that in a world where data privacy, security, compliance regulation are becoming more and more important, organizations need to be able to carefully define, monitor, and manage who has access to the specific pieces of data. And finally, on top of these challenges, the pandemic last year and still this year has been hard and disruptive. And it's really been very challenging for so many of our customers. So what our customers have told us during this pandemic is to survive, you need to cut costs, save time, perform at scale, and make faster and better decisions in a difficult business environment. And those who thrive, they need a modern data strategy that will grow with them in the future. Organizations are already looking into this, and the pandemic really put that at the forefront. You want to really build a data foundation that modernizes your data infrastructure, puts your data to work, and invents new experiences. This way, you can stay relevant in the future and when things go back to normal. So now let's look at an example of what this really means. Let's look at the Walt Disney Company. They've been relying on AWS to support the explosive growth of Disney Plus, which reached its 5-year goal of 100 million subscribers only 8 months after launching in 2019. This is a testament to the hard work that the team at Disney is doing and how they are leveraging AWS services to help them get there. Disney Plus uses machine learning, database storage, content delivery, serverless, and analytics from AWS. For example, Disney Plus uses Amazon Kinesis and Amazon DynamoDB to ingest content, metadata, and billions of customer action each day, which enable viewers to add content to the watch list, start a video from one device and picking it up on a different device, or even make recommendations for what to watch next. Disney Plus is also using Amazon Time Stream to monitor the efficacy of their streaming platform to make sure that their user continue to have access to the highest quality of video content. They are able to handle, when they actually started in November, they were able to handle 10 million new Disney Plus sign up within 24 hours. And then now they've expanded to handle 3 billion requests for Disney Plus content in the first 3 days after launching the service. So Disney is a good example of a traditional organization that has been able to adapt and serve its customer in an entirely different way. To do this, they took advantages of some of the trends that we see with organizations that are building a modern data strategy. As customers move their data to the cloud, they are rethinking how they build their application. Early cloud adopters raced to build new experiences for us. These builders face a completely different set of requirements than previous generation. They've been trying to understand the scale and the performance when millions of users are buying things online, deciding what movie to watch, ordering a ride share, or taking a selfie with low latency. So developers are building the application with microservice architectures, allowing them to break these large applications into smaller services, picking the right database and the right tool for the job. For example, you have an application where your search function can use Amazon OpenSearch. Your order or sales data uses a relational database such as Aurora for transactional data. Your customer reviews is using a key value database such as DynamoDB because it really is designed for high performance at any scale. And your recommendation items use a graph database such as Amazon Neptune because it can store relationship between data and find connection. Each of these modules uses a purpose-built database for the specific job. However, these existing approaches to data do not always work. Traditionally, analytics was run through a relational data warehouse. It collects data from multiple sources systems and produces operational reports. The systems were not built to handle exponential growth of data for things like log files, clickstream data, or even machine-generated data from IoT devices. Instead, customers are moving to data lakes to store and analyze structured and unstructured data into a single place and performing different types of analytics, including machine learning. So what you need is a modern data strategy to handle all of this. So a modern data strategy gives you the best of both data lakes and purpose-built data stores. It enables you to store any amount of data at low cost in open, standard-based data formats. It lets you break down data silos, empowers your team to run analytics and machine learning using their preferred tool or technique, and manage who has access to the data with proper security and data governance control. So what does a modern data strategy looks like? It really comes down to these few things. The first one is data at any scale. The second one is the best price performance for all your applications and analytics. So AWS actually has the broadest and deepest set of purpose-built data services that have been optimized to give you the best-in-class functionality for all your workloads. The third one is the ability to access your data, having security and governance. And AWS automatically discovers, tags, catalog, and keeps your data in sync across your data lake, your data warehouses, and your purpose-built data stores. And finally, the last thing that you need for a modern data strategy is AI and ML to solve business challenges. So whether you want to enhance your customer experience, improve productivity, or optimize processes, or even speed up or scale up innovation, you can access the most complete sets of ML and AI services at AWS to meet your need. So what it really means for data at any scale, it starts with S3. S3 gives you an unmatched availability, scalability, durability, governance capabilities, security, and cost-effective performance. And for the purpose-built data stores that are built for price performance, we do offer engines for databases and analytics. So for databases, we have anything including relational, key value, document, in-memory, graph, time series, wide column, and ledger databases. And on the analytics front, we offer services optimized for your unique use cases, including data warehousing, big data processing, interactive analytics, real-time analytics, operational analytics, and visualization. So we do offer all these services, and including AI and ML services for any type of industry and use cases. On the governance front, you can essentially define and manage security governance and auditing policies to satisfy regulations specific to your industry and your regulation. On the AI and ML front, AWS has services that aggregate and prepare data and solutions that are built for specific industry use cases. So you can really build, train, and deploy machine learning models quickly using Amazon SageMaker, a fully managed service that provides the tools required for every step of the ML development lifecycle in one integrated environment. As we've just covered, many companies are taking all their data from various silos and aggregating all their data into one location. Usually it is a data lake to do analytics and machine learning on top of that data. So that means there's a lot of movement that's happening with your data. And that movement can be inside out, outside in, or around the perimeter because your data has gravity. Let's start with inside out. This is when organization, in addition to using a data lake, they are also using a rings of purpose-built data store to get the best performance, the scale, and cost advantages for their use cases. So the way the data moves inside out, you actually move the data from inside the data lake to the different purpose-built data store. One example is if you have clickstream data from a web application that's being collected, directed into your data lake, you can move portion of that data into a data warehouse for daily reporting. After that, you can also move that data the other way, so outside in. And this is when you are really moving the data from your different purpose-built data stores into the data lake. A good example is you can copy query results for sales of your product in a given region from a data warehouse into your data lake to run product recommendation algorithm against a larger set of data using machine learning. And finally, your data moves around the perimeter. This is when your data moves from one data store to another purpose-built data store. And a good example for that is when you copy the product catalog store in your database to your search service in order to make it easier to look through your product catalog and offload the search queries from your database. In that case, you actually get better performance from your database and low latency for your end customer. So it's very clear that the next wave of digital transformation will come from data. And AWS can help you in three ways. We can help you by modernizing your data infrastructure with the most scalable, trusted, and secure cloud provider. Organizations that are running legacy on-premise data stores or even self-managing in the cloud still have to take care of management tasks such as database provisioning, patching, configuration, or backups. So when you modernize your data infrastructure, AWS takes care of this for you. So you can really benefit from AWS's unmatched experience, reliability, security, and performance so that you can depend upon us to build your most important application. The second way AWS can help you is by unifying everything. So that's where you put your data to work and using the best of both data lake and purpose-built data stores. To make decision quickly, you will need these new data stores that will scale and grow as your business needs are changing. You will also want to be able to connect everything together, including your database, your data lakes, your data warehouses with all the different purpose-built data store into a coherent system that is secure and well-governed. And AWS help you through this with the different purpose-built data stores that we have and our data lake offering. The third way is innovate. So this is where you really build new experiences and reimagine old processes using machine learning and artificial intelligence. Machine learning is one of the most disruptive technologies of our generation. It can help you create entirely new revenue opportunities, making better and faster decisions, improving operational efficiencies for your customers. And here, AWS meets you where you are in your journey. We have the broadest and most complete set of ML and AI services for builders of all levels of experiences. For the purpose of today, we'll only focus on one of these three ways AWS can help you, is when you put your data to work with us and using both data lakes and purpose-built data stores. Let's start with a customer example. Equinox Fitness has a number of health and fitness brands, including SoulCycle. They shifted from Teradata, which was very expensive and was not scaling for them, to Redshift Spectrum, EMR, and Athena. They use S3 as their data lake, and they've saved a lot of money this way. So, for example, their monthly Redshift bill is 20% of their yearly maintenance cost on Teradata. So, for example, with Teradata, and if let's say, for example, you paid $1 million for your data warehouse upfront fees, then what these vendors will do, they will charge you like 20% every year for software maintenance and upgrades. So when you migrate this to Redshift, you actually end up saving so much money. So Redshift really costs less a year than what you would be paying for maintenance costs in everywhere else. And with this, you don't have to pay any upfront fees. Another example that we have is Engie. Engie is a global energy company located in France. They've got 25 business units operating worldwide. So this company powers millions of customers and develops integrated solutions throughout the value chain to support corporations, local authorities with zero carbon transition. So Engie was struggling to have all their data in one place. They have got 160,000 employees worldwide, and they were operating in a decentralized way. So in 2018, Engie decided to accelerate its digital transformation through data and innovation by becoming a data-driven company. To do that, they built their data lake, which they are calling Common Data Hub on AWS. And this data lake unites all the business units in one place, allowing them to ingest, store, share, and consume data set through a unified platform and highly secure environment. As a result, Engie has been able to collect 95 terabytes of data across 351 projects. They've automated energy predictions and maximized wind farm energy production. So Engie is one of those organizations that have been able to use the different AWS services, including Redshift, Glue, Kinesis, Athena, Amazon SageMaker, and S3 to be able to serve their customers. And they were able to do that because they were using what we are calling AWS a lakehouse approach, or a modern data strategy, which really connects your data lake, your data warehouse, and all your purpose-built data stores into a coherent whole. And for us at AWS, it really starts in the middle where you see with S3, and that's where you use to build your data lake. In addition to the data lake, customers are using a combination of purpose-built databases and analytics services, including EMR, Amazon OpenSearch, and Redshift, to ensure that they are using the right tool for the right job, and they are able to get the performance and scale at the lowest possible cost. These same customers are able to unify their data access. They are using AWS Glue, our serverless data integration service. And finally, they are also using Amazon SageMaker to do machine learning to innovate on top of their data. So let's talk about the first pillar of a modern data strategy, or the first pillar of lakehouse. The first one is being able to store your data at any scale, and we are putting this data into scalable data lakes. With AWS, you can move and store any amount of data from various silos into Amazon S3 data lake in standard-based open data formats, and avoid being locked into one analytics approach. And S3 gives you unmatched availability, scalability, reliability, security, and governance capabilities at a price performance that is really unmatched in the market. So S3 was really built from the ground up to deliver 99.9, so 11 nines of durabilities. It offers you the best security, compliance, and audit capabilities. You are able to have the fastest performance for your data lake at a lower cost, and you are able to bring data from different places and different sources into your data lake. And so with this, you really get three benefits. The first one is avoid being locked into any proprietary data formats or approach to your analytics, making it easy for any of analytics and machine learning services to work on that data. And finally, you're able to eliminate the need to move, transform, and reformat the data in order to get value from it. And to build a data lake, we have AWS Lake Formation. So AWS Lake Formation helps you build and secure data lakes in the cloud in just a few days instead of months. With AWS Lake Formation, you can move, store, catalog, and clean your data faster. All you have to do is simply point AWS Lake Formation at your data sources, and Lake Formation crawls those sources and register the data with your Amazon S3 data lake for analytics and machine learning. AWS Lake Formation simplifies security management for you, so it provides a secure access to your sensitive data. And your user can access a centralized data catalog, which describes available data sets and appropriate data usage. And then it leverages these data sets with their choices of analytics and ML services. And finally, AWS Lake Formation makes it easier for you to find and access your data. So it helps you build a data catalog that describes different data sets that are available and provides a central catalog of data to your customers. So it's easier for your analysts and data scientists to find and access the data that they need. And all these capabilities are why more data lakes are running on AWS than anywhere else. So you have companies such as Vanguard, BMW, GE Healthcare, Zillow, Slack, and many more. And AWS has really been helping customers build a strong foundation for their data with data lakes with services such as S3 for many, many years. The second pillar is that our services are purpose-built for performance and cost. So we provide the broadest and deepest set of data services optimized to give you the best-in-class functionality for your workload. So with AWS, you just choose the right tool for the right job. That way, you really don't have to compromise on functionality, scale, performance, or cost. And our customers are using these different purpose-built analytics services on top of their data lake in S3 to solve various big data use cases by storing and processing data in a way that is optimized for the particular use case that they have. So, for example, if you want to do ad hoc querying on your data that's directly on your S3 data lake, you can use Athena just using standard SQL. And if you want to process vast amounts of unstructured data across dynamically scalable clusters using popular distributed frameworks like Spark, Hadoop, or Presto, we've got a service called EMR. So EMR also runs directly against the data that is stored in your S3 data lake. So you don't have to move the data. You can just, or even transform it. You can just access the data where it is. And if you want to quickly search or analyze large amounts of log data, you can use Amazon OpenSearch, which is a successor to Amazon Elasticsearch service. And finally, if you want to do real-time processing of streaming data, we've got Amazon Kinesis and MSK. And if you have structured data or you want super fast querying results, you want a data warehouse like Redshift, which was the first data warehouse built for the cloud and really has disrupted the economics of data warehousing. So with these different purpose-built data services, let's talk about each one of them just to give you an overview of what they are. Let's start with Redshift. So Redshift is the only cloud data warehouse that lets you run queries at exabyte scale against your data, while also enabling querying of operational data stores such as Amazon Aurora. It continues to be the most widely used data warehouse in the cloud with tens of thousands of customers. You have customers such as Johnson & Johnson, Redfin, Warner's Brother. As I mentioned earlier, Redshift gives you 3 times better price performance than any other cloud data warehouse, and the price performance advantage improves your as your data grows from gigabytes to exabytes. The reason why Redshift is able to do any of this is because its architecture has been reinvented to take advantage of AWS design hardware and machine learning to deliver the best price performance at any scale. So to deliver the best price performance, Redshift uses AWS design hardware such as Nitro system and EC2 to accelerate common data warehousing functions such as data compression and encryption. And we've got a tool called Aqua, which is a new distributed hardware accelerated cache that allows Redshift queries to run up to 10 times faster than any other cloud enterprise data warehouses. And Redshift takes advantage of the highest networking bandwidth available to move data between your local data storage in S3 and giving you the fastest query response time for your largest and most demanding workloads. It also uses advanced machine learning techniques to analyze queries, graph optimization algorithm to automatically organize and store data for the fastest query result. And to keep costs low, Redshift moves data between your local data warehouse storage and S3 based on how frequently your data is being accessed. So Redshift really integrates with your data lakes and purpose-built data stores, and also with other machine learning tools so that you can analyze your data in one single place. Now let's talk about EMR. So EMR makes it easy to process petabyte scale data using the latest open source big data frameworks such as Spark, Hive, Presto, HBase, Flink, and Hudi. And like Athena, EMR runs directly against the data store in your S3 data lake, so you really don't have to move any of your data to get insight from it. You can easily create clusters and provision one or even hundreds or thousands of compute instances to process data really at any scale. And EMR automatically manages cluster sizes up and down based on your utilization, so you only pay for what you use. EMR also decouples compute and storage, giving you the ability to scale each independently. So for storage, you can take advantage of tier storage in Amazon S3. And then for compute, you can take advantage of EC2 spot instances to save up to 80% of costs using on-demand instances. So we launched the first version of EMR in 2009. So that's more than 10 years, and are continually innovating in areas such as performance to make sure that EMR is the best place to run your Spark workloads, as well as workloads of other frameworks such as Presto and Hive. Now let's talk about Amazon OpenSearch. Amazon OpenSearch used to be called Amazon Elasticsearch Service. It makes it simple to collect, analyze, and visualize unstructured and semi-structured machine-generated log data from websites, mobile devices, servers, sensors, etc. A good example of a company that's been utilizing OpenSearch is Autodesk. Autodesk now captures 2 terabytes of activity log data across their application every day, and they expect that to grow to 10 terabytes a day in the next couple of years. So they use OpenSearch to collect, index, and analyze those logs in real time to better identify trends and patterns for anomalies, so that they can resolve error faster and improve the overall mean time to recover from their application. And Amazon OpenSearch Service provide OpenSearch APIs. It's a fully managed service, so you really can deploy a production-ready OpenSearch, Elasticsearch, different versions uh, in minutes, and scale your cluster up and down via a single API or just a few clicks. And finally, Amazon Open Search Service uses machine learning to detect anomalies in real time and auto-tunes your clusters and personalizes your search results. Outside of log file, we also have a service called Kinesis, which really processes real-time data from video to other kind of data stream data. So we've got Kinesis data stream, which is scalable and durable uh, service for real-time streaming data. We've got Kinesis Data Firehose, which is the easiest way to reliably load streaming data into data lakes, to different data stores that we offer, and using different analytics tools. We've got Kinesis Data Analytics, which is the easiest way to analyze streaming data, gain actionable insights, and respond to your business and customer needs in real time. So with Kinesis Data Analytics, you can build sophisticated application using Apache Flink, which is an open source framework and engine for processing data streams. And finally, we've got Kinesis video streams, which makes it easy to stream video from connected devices to AWS for analytics, machine learning, playback, and any type of processing that you need. So with video stream, you can durably store, encrypt, indexes data in your streams and allow you to access your data through an easy-to-use API. We've got a second streaming service, which is MSK. And MSK stands for Managed Streaming for Apache Kafka. So with MSK, you get actionable insight from streaming data with serverless Apache Flink. And this service is, as I said earlier, it's compatible with Kafka. It's fully managed, highly available, and secure for all your data needs. The other pillar that we've got for this modern data strategy is really being able to access your data wherever it is. And AWS allows you to easily access and keep your data in sync regardless of where the data is. So whether the data is in a data lake or in a different data store, you are able to access that data seamlessly. And to do that, we've got a service called Glue. And Glue is a serverless data integration service that makes it easy to prepare data for analytics, machine learning, and application development. Glue provides all the capabilities needed for data integration, so you can just gain insight from your data and put all your data to use in a few minutes instead of a process that will take months. AWS Glue provides you with both visual and code-based interfaces to make data integration easy. User can easily find or access data using AWS Glue Data Catalog. You've got data engineers and ETL developers who can easily and create, run, and monitor ETL workflows with just a few clicks using AWS Glue Studio. And then you've got data analysts and data scientists who are using AWS Glue Data Brew to visually enrich, clean, and normalize data without writing any code. As more and more organizations store their data in S3 data lakes and purpose-built data store, they often need to move their data back and forth between those data lakes, the data warehouses, and different data services. And so really, AWS Glue allows you to build complex data integration pipeline that collects, combine, and keep your data up to date. And customers really love the scalability and flexibility of AWS Glue. So Our services and features include ETL, visual data preparation, data replication, movement to and from your data lake to the different data warehouses, and federated querying. And so we've got services like Glue, which helps you do that. But we also have other services such as Redshift Spectrum or Redshift Data Extract, which are helping you with the same purpose. The fourth leg of a lakehouse architecture or a modern data strategy is this idea of unified governance. So really, you can centrally define and manage security in one place. And then you can also add like auditing policies to satisfy regulations specific to your industry or your geography. And AWS allows you to do that. I'll help you to do that using AWS Lake Formation, which has been able to empower developers, business analysts, data scientists, really breaking down those different data silos and able to analyze data in a secure and more governed way. So what AWS Lake Formation ends up doing is they're able to provide an easy way to centrally define and manage security, governance, and auditing policies in one place, making it easier for all the people in your organization that are using data. And so this really just helps your organization provide fine-grained access to data to the right user at the right time, so people really have access to the data that they need and following the different compliance and regulation that exists in your specific industry. The last piece that we offer with our modern data strategy is really how we add ML to the different services that we have. And most of the people that are using our services do not have to have prior machine learning experience. So whether you really want to enhance your customer experience or improve the productivity of your team, or even just like change your existing processes or increase innovation. So we do provide you with a set of machine learning and artificial intelligence services to help meet your need. And AWS allows you with Amazon SageMaker to train, deploy, and build machine learning models very quickly. And so we are able to support you with all your machine learning needs at any step of your ML development lifecycle in one integrated environment. So as I said earlier, we are bringing machine learning closer to data. So we've got Amazon SageMaker and other ML services directly into your database for developers to use, for data analysts, business analysts to use every day. So our customers use different type of data stores like relational, non-relational data warehouses for the different use cases, and we are allowing them to do that easily by adding ML on top of that. So they are able to gain the benefits of using ML without having to have any type of ML experience. So we've built ML products for databases, including Aura ML, which is integrated with SageMaker, Neptune ML, Redshift ML, Athena ML, and Amazon QuickSight ML. So we are really bringing machine learning closer to our different data services. And so what you will do, for example, with Redshift ML, our customers are able to process exabytes of data to power their analytics workloads. They are using that with ML, and most of them don't need to have any prior ML experience. So you can actually query using just your standard SQL and be able to gain advantages that you would get with machine learning. And one example, as I mentioned earlier, is Redshift ML, which you can use without no ML experience required. You are able to train and deploy different ML models just using SQL which is a language that most data analysts, business analysts, and data scientists are used to using. And then you can also gain fast prediction from your the data that's in your data warehouse, just using SQL commands within a Redshift environment. So to recap, it's very clear that harnessing data is what's going to drive the next digital transformation. And so it's very critical for you to modernize your data infrastructure, unify the best of both data lakes and purpose-built data stores, and add machine learning on top of that to build new experiences and reimagine old processes. And AWS is here to support you along the journey, regardless of where you are in the journey. And while we offer you these 3 steps, modernize, unify, and innovate, you can start anywhere, and we are able to support you regardless of where you are in this journey. Thank you so much for taking the time to spend your day with me today. So here's my email. You can reach out to me directly if you have any questions. And then you can go to aws.amazon.com/data to see everything that we have in terms of resources on how you can bring all your data needs in one place. Thank you.